we head back over to the server, we're going to be making some of the same imports here. So I'll just paste those here. The other thing is we will also want to have a logger and a socket set up on the client, albeit the client will be a bit different here. So I'm going to just go ahead and copy these methods out, and we'll paste them here. We should probably abstract out the logger into a separate class here so that we don't have so much duplicate code, but for now we'll just keep it simple. Okay, so what's different about our client though is we're not going to be binding here. Instead, we're going to be using the connect method. And so we're going to want to connect this client over the same host and port to the server. And so we can also get rid of .listen here. So what's the responsibility of the chat client? Well, first of all, it needs to connect to a server, and then it needs to send messages to that server. Concurrently though, we also want our client to receive any incoming messages sent, proxied by the server back to our client. And so we need to actually run those two things in parallel, if you were. We need to run them concurrently anyway. So in order to do that, let's think about it for a minute. We could use Python thread here. We can use the threading library. So what we're going to do is import, from threading, we're going to import thread. And there's definitely a bunch of different ways that we could actually implement this concurrency. Depending on the method that we choose, it's going to have different performance implications and complexity implications. For now though, we're going to use a basic thread for our client, which should serve our purposes fine for the initial version of this app. So what we want our client to do is, once we've set up this socket and we've connected over the specified host and port, what I want to do is create a new thread, and we're going to give it a target for sending messages. So we want to be able to send these messages concurrently to listening for any incoming messages. We're going to make sure it's a daemon thread. Alright, so that's going to be started. Nothing should be blocking there. So what we will do though is, once that thread is started in the client, we're going to dangerously while true again here, and we're going to receive data over the socket. And for that, we use this .recv method. Interestingly, the naming here, I believe, comes from the underlying C implementation of sockets here, which is where we get this recv method from. In any case, we will be running this as a byte stream again, and so what we're going to do is specify a buffer here. And so since this is a stream, it's going to be receiving data in chunks. And the buffer here is the buffer length here is just going to tell us how many bytes we'd like to receive in each chunk. If not data, so if for some reason we're unable to receive data from the server, which is going to happen if the server disconnects or the process terminates or has an error for some reason, then we're going to break out of our client while true loop here. In any other case here, we're just going to use our logger instance to log out the data that we receive from the server to the terminal. And that data is going to be sent as bytes, so we're just going to go ahead and decode it here when we log it out to our terminal. Alright, so we need to actually implement this method sendMessage that we're going to be running on a separate thread now. This is pretty simple. Again, the interface, or the implementation on the socket interface here is really high level. Once again, we'll be running in a loop here infinitely. We're going to take some input from the user, from the terminal. So I'm just going to call this, what can we call it, like user message is equal to input. And now we're going to use the instance of the socket that the client is managing and send that encoded as UTF bytes here. The other thing we can do is we can specify some behavior on encode when we have some failure to encode. So for instance, we could ignore it. What I like to do sometimes is say \replace, and this is just going to replace any errors here with the with that like sort of \n notation. We have a basic client. We're able to send messages on a separate thread than on the receive thread here. I haven't checked very closely to see whether or not we have any typos or anything like that. So let's go ahead and try to fire up our server and our client. And I just realized that if we want to fire up a client here, I should probably write a script to do that. So we'll say if name equals main. Then we'll new up a client here, chat client. And for now, we'll just connect on localhost. And for the port, we'll connect on like, I don't know, 4333. Likewise, over in our server, I'm going to say if name equals main. We'll say server is equal to a new chat server, which will be running on localhost 4333. And then in the case of our server, we need to invoke the run method to get it going. So I'm going to go ahead and cd into our project directory. So I'm going to go up one directory here, and we're going to source env bin activate. And then I'll cd into simple chat, and we'll run our server. Okay, so we can see that the chat server is running. I'm going to open up another tmux pane here. Go into our project directory and activate again. Go into simple chat, and we'll run an instance of our client. Oops, and we're getting an error here that init takes one positional argument, but 3 were given. And that is because we need to specify the host and the port on our client here, which I did not do. Okay, let's try to run our client again. Now I'm getting an attribute error. Chat client has no attribute socket. So let's go back to our chat client. And that's right, because we called it sock. So we'll go ahead and self.sock.receive. and self.sock.send. Okay, cool. So in both cases, we could see nonetheless that we connected to our chat server, and I can send things to the server, but our server isn't really doing anything right now except showing us new connections. So let's go ahead and wire it up to relay messages from the various connected clients. So I'm going to head back over into server.py. And so we have this while true method that's accepting new connections, and we're using the logger to basically print to the terminal any new connection that's made. Like the client though, the server has a couple of responsibilities. First of all, it needs to be accepting new incoming connections. But then second of all, it also needs to be relaying messages to clients when clients are sending the server messages. So the server also has this sort of double duty. And so we could use threading once again here to implement this concurrently. I'm going to do it a little bit differently here in the server, I think. I'm going to use basically a thread pool. So in Python, we have this thread pool executor from concurrent futures that I can just import from concurrent.futures, import thread pool executor. So a thread pool executor is just going to manage a set of worker threads, and so we can sort of pass tasks to them as they become available for work. So in our case, the task is going to be basically just to relay messages. It might be overkill to do it this way, but I just kind of want to try it out and see how it works. So outside of our while true loop, what I'm going to do is say with concurrent.futures.threadPool as executor. This with is a context manager, and so it should join threads when exiting. So while true, we're going to block on accept here until we have a new connection. But we'll basically use the executor to submit, and here we pass it the function and the arguments that we want to send. So let's create this method relay messages, and we'll send it a connection and address. Maybe we'll also have the chat server sort of keep track of the list of connections that it's managing here. So we'll say self.connections. For now, we'll make it an empty list. And underneath new connection here, I can also logger.debug, and we'll just say connections, self.connections. And anytime we have this new connection, we'll just push that onto the list. So connections.append, the new connection. Now we have this executor.submit, self.relay messages, and then the args. So let's go ahead and make that relay messages method. So it takes in the connection and address. And here we'll run this in a for loop. This is a little sloppy. We can clean this up in a bit. But for now, just to get it working, we're going to be running this relay messages on this thread in a while true loop. So the data that we receive from our connection, we can receive just like we did in the client. And I'm trying to remember how many, what the buffer length was. I did 4096. So we'll do the same here. And so how are we going to relay the data? So for now, we can just do a simple for loop. We can say for connection in self.connections, connection.send data. So nothing fancy here. We just relay the data sent by one client to all of the connected clients. If not data, similar to the behavior of our client, I'm just going to go ahead and log a warning here that says no data exiting, and then we can break. Okay, so we should have some basic relay behavior here. So let's go ahead and try to test it out here. So I'm going to kill the server. You can see that when I kill the server, the client also dies. So python server.py. Oops, concurrent is not defined. Oops, well, I imported threadpool executor. So we shouldn't need to specify the namespace. Okay, chat server is running. Okay, so now when I type hello, you can see that I'm getting, well, the output back from the server, what I just typed into the console here. So that's pretty cool. We can actually distinguish between that a little bit more clearly here if when I relay all those messages, maybe we put something in, in front of that string. So I'm going to go back to the client. Oops, sorry, I'm going to go back to the server. And when it's relaying messages, it sends data, but maybe we'll also send like the address. Maybe we'll just like separate that with a pipe or something. Yep, and I'm getting an address already in use error, which I've seen this before, and I'm pretty sure that there's a way to set this up so that we can reuse a host and a port. And the way that I think that we do that is on the server if we go back down here to server, chat server. And the way that we do that, I think, is when we create our socket, after we've created it and before we've bound it, we can do this set sock opt socket.sol socket and socket.so reuse address. According to the docs, this reuse address flag tells the kernel to reuse a local socket in time wait state without waiting for its natural timeout to expire. That's what the docs say. In fact, this set sock opt is a BSD call. So I think if we man set sock opt, get and set options on sockets. So I wonder if we can actually see, yeah, so we can see the flags that we're setting here. So this enables a local address for reuse. And it's cool to see some of the other flags here. SO linger. In any case, this might be interesting to read through one time. Okay, so I'm going to try to set this option on our socket. I'm not sure if it's going to work. If it doesn't work for the purposes of this tutorial, then what I may do is just for now change the socket number for the sake of expediency. Socket object has no attribute SOL socket, so we actually need to import that, I believe. Oh, get rid of the namespaces here. Okay, so let's try again. Alright, so our chat server is running again, and we have a new client connected. Oops, and it looks like our messaging is not coming back out to, or not getting relayed anyway here. So I'm going to head back over here. I'm going to get rid of this change that we had here. And I'm going to restart the client and the server. Okay, so now we're getting data relayed back out to our client. But again, I want to sort of prefix the output when it's being relayed from the server. So I wonder if I actually do something like, maybe like str address dot encode UTF-8. Yeah, so now we can see that we get this address back out. Maybe I'll grab the first index of the tuple here. And so we'll just grab that, and then maybe what I'll also do here is we can print out the date time or something. So I'll import date time. And I'll say now is equal to datetime dot now. And we'll string format it, so we can stir f time. And we'll give it sort of a standard string formatting of year, month, day, hour, minutes. And I'll just say now.now.encode as UTF-8. And maybe I'll also add like a separator here. So we can say like now plus equals this. Okay. So we'll go ahead and stop the server. Oops, I forgot to. Okay, so let's head back to the terminal. And so now we can see that we're getting the IP address and the time and then the message. So likewise, if I was to connect to this in another process, which we could actually just do here, we should see the message from all of the clients getting relayed by the server to each other. So let's go ahead and start another client. So we can see that another client was connected here. And say like hi from client 2. And so you can see client 1 is getting all of the messages, as is client 2. Okay, so we have a very simple implementation. We've basically got this relay server that just relays all the messages from any connected clients back to each other. Let's see if we can actually run this in a Docker container now.